I'm going to do a review on this mystery item. Oops. I'm going to do a review on this mystery item. What's in the bag? You'll never guess. Guess is down below in the comments. Don't forget to click like and subscribe if you like the channel. So in here we have a few things. Now this is a review item from Banggood. I requested this. I want to do a bunch of review videos and accuracy tests on low cost multimeters. And the AN8008 is one of them. From Aneng, I don't know how you pronounce it. Let's have a dig in. This is one of a few multimeters I'm going to be working on. We're going to do some accuracy testing on it and see how good it appears to be based on what I can measure with my equipment here. So also got some standard probes. These would be PVC leads, I think. Seem quite stiff, so they're probably PVC. Got shielded probes. So it's Cat 2 1000 volt, Cat 3 600 volt probes. Claims the same thing on the front panel here. 10 amps and 200 milliamps current ranges, and obviously the various other functions such as AC DC volts with percentage of hertz, so it's duty cycle, millivolts, capacitance, diode tests, beeper and resistance on that one there. I'm guessing you use this button here to change ranges, hertz and percentages, amps, milliamps, microamps as well. And it's also got an output which is a square wave output, which I think is quite interesting. I think I must step through. I wonder what that's been used for. There must be some function for that which people may want it for, but I don't know. Interesting. So I also got this accessory pack came with it. So we've got two packs. We've got this standard lead set. We've also got this one here which has got all these screw-in tips and things like that. So you've got these standard tips which screw in. You've got some crocodile clips and some other like pro tips and stuff in there as well. Some spade terminals. And basically leads, you've got these threaded connections on them. Could be handy for things. Anyway, let's have a look at this thing. And don't forget, check out the links down below for Banggood, where you can use my purchase links to get these at maybe a discount, I'm not sure. Usually it's a discount. At the very least I'll get a commission for anything you buy through Banggood, and this helps support the channel. Helps me to buy bits and pieces and get review items from Banggood and other suppliers. So on the back here you've got this foldable leg. It's a little bit flimsy for my liking. Maybe fine. I mean, can I turn this? I mean, my desk is a bit slippery anyway. It's not great with the surface on it for trying to do things. I do have to basically support things when I'm doing them anyway myself, so because this is a slippery surface. Yeah, the switch feels nice enough. It feels alright. If you're pushing buttons, yeah, it's probably just enough. I mean, it's got a little bit more flex than I'd like. Anyway, under here is a screw to get the batteries out. Well, I'll put them in. In this case, when I put them in, let's do that. Maybe hear the fan noise of my Datron calibrator, which is currently warming up, so we can do some accuracy tests. Oh, that whole thing comes off. Oh, interesting. That's how it's assembled. Alright. It takes two AAAs. Okay, let's get some. Probably don't need to see this though. Probably not. Oh, it's turned on. Guess I left the switch in the wrong place. That was a threaded insert, wasn't it? Yes, it was. So it's actually a threaded insert. We might do a teardown this too. Here we go. Oh, we've got to do a peel too. We've got a screen protector. Well, that's got to come off, hasn't it? Here we go. These tweezers. I need to put some music on that. So something that's quite important to me quite often is the spacing of the terminals. And these ones are the standard spacing. Excellent. Alright, so plug leads in. Let's start here. Let's start in the middle, because starting in the middle is always a good thing to do. It's a nice display actually, it's quite sizable. It's quite big. Let's just pull these covers off. This makes it a bit easier to do what I'm doing. Stick them together. Lead resistance 0.13 ohms. So we're getting diode test, buzzer and capacitance. So this is diode test right now. This would be capacitance. Yep, okay. Back to resistance again. And there's the continuity buzzer. This is what I'm going to test. How quick is this? Oh, that's fast. That is really fast. That's good. That is very good. That is actually very impressive. That's actually really good. So what I'm going to do next is move this over to my calibrator there. We'll hook up to the calibrator and we'll go through and check the ranges that we can on the calibrator. So these are the specifications for the multimeter. So it's actually not looking too bad. It's like 0.5% for DC, 1% for AC, 0.5 for something else down there, so resistance. 2% for capacitance, which is not that unsurprising. Capacitance is always a hard range to get right. And frequency, 0.1%. This is a 9900 count meter, so it's basically 10,000 count, goes to 9999, as can be seen here. 1 volt range, 10 volts, 100 volts, and 1000 volt range. And same for AC, apart from goes 750 volts to 1000 volts. So you get an idea anyway, you can see that for yourself. Look at the specs yourself. So we're going to try and just see how it looks. Square wave output, which is the output I was mentioning before. 50 Hz, 100 Hz, 200. So these are the ones that will set through on the output, which is an interesting feature. Maybe I'll look at that on a scope or something. Maybe. So here we are over at the calibrator. A bit of a jerry-rig setup here, trying to get things to sort of be in place and line up and stuff. So things are resting around. Let's excuse it. I don't normally have a setup here for stacking things up. We've got 0 volts output, 0 volts on DC on here. So let's do the 1 volt range first. Exactly 1 volt. 1 count's changing round. But that's fine, that's pretty much acceptable, isn't it? That's good. Okay, let's do 10 volt range. So that's just 1 count out. That's not bad. Just 1 count flicking on and off. Oh, maybe 2. 100 volts. 100.1. Oh, yeah, sort of. Basically 1 count out still. It's 1 count, still not bad. That's well within spec. So what I'll do now is drop this down. I'm going to start at 500 volts. This is going to start beeping. So, yeah, okay. It's about 8-9 counts out there. Okay, it's about 1.5 counts out there. 1000 volts. It's not liking that because it's reading slightly high. So because it's reading high, it thinks it's more than 1000 volts going in. So 1000 volts is 998. So it's out by 2 volts in the 1000 volt range. Okay, let's bring this down a bit. Let's try 300. Yeah, okay. So I actually think that 100 volts might be where it's calibrated. So now I'm doing 1 volt AC and it's reading exactly 1 volt AC at 1 kilohertz. Actually, let's just change frequencies and let's see what we get. Let's do 10 kilohertz. Can't read that. 100 hertz. Can read that. Okay, that's fine. Which is what you want. You want it to be sort of 50 to 100 hertz. So 50 hertz. Yeah, that's fine. 30 hertz still reading. 10 hertz still reading. That's actually not bad. It's a bit jumpy because it's 10 hertz, you know, it's going to expect that. 20 hertz is stable again, that's good. So let's find out where it cuts out. 3 kilohertz is not reading very well. 2 kilohertz is dropping down slightly. So let's just see where the accuracy drops off. I mean, I think that's just basically the spec there, wasn't it? 1% or something. So 1.2 kilohertz. Okay. Let's see what the spec said about that. So the actual spec said 40 hertz to 1 kilohertz. So it's actually exceeding the spec, which is good. That means it's actually true. It's nice. Let's do 1 kilohertz. Because that is part of the spec, so it should be in that range there. Let's do 10 volts. 1 count out, the same as DC. Let's do 100 volts. 100 volts, 2 counts out. Because I think it's 1% spec was AC. And brightly 1% was AC, so it could actually be 101 is the worst it could be out by. Plus I think a couple of counts as well maybe. So that's actually looking really good. So let's drop this down. Again, this can only do the 750, which is quite common. So start 400. Yep, that's not too bad there. 800 should be beeping, yep. 700, yep. But they're still well within specs, you know, 1% could be 707, so that's fine. So now I'm doing the millivolt range, so this is 10 millivolts DC, and it's basically bang on. Let's do 1 millivolt. A few counts out there. still within spec, 100 microvolt, again a few counts out. So that seems fine. So we are doing 1 millivolt AC at 1 kilohertz, fluctuating a little bit. When you get to these low levels like this, noise and EMF interference, stuff like that, can cause problems. You know, AC power line noise and common mode stuff, it can be problematic. So you do get induced noise that way. It can cause fluctuations because of that. But it's basically reading right, so it's good. That's well within spec. 10 millivolts, and also a couple of counts out, but that's fine. Let's drop the frequency down a bit. So 100 hertz, again, only a couple of counts out. Nothing wrong with that. So I've gone back to this main mode over here because it does frequency over here. So I've got it set to 100 hertz still, and that's measuring basically one count out. 10 hertz, 61 kilohertz, that's one count out. 10 kilohertz, that's fine, one count out still. 100 kilohertz, it's struggling with that one, I can't read that one. Okay, I'm not sure what it's supposed to go up to, I don't remember. Let's try 50. Yeah, struggling at 50. Let me check the specs. 40 is fine. Well, it's supposed to be able to do up to 10 megahertz, so maybe my voltage is a bit low for it or something. So let's go to a high voltage. Up the frequency again. 100 kilohertz. There you go. Now you can read it. So obviously voltage dependent, which is quite common for frequency measurements. It needs to be able to get a fast enough edge. That's fine now. So that's reading that. Let's try 1 megahertz. Supposed to say 10 megahertz. What it's supposed to do. So we do 1 megahertz there, and we're not quite there. Let's bump the voltage up a bit more. There we go. See. So going to be like 20 volts AC to get the 1 megahertz reading on there. That's potentially problematic for you if you're trying to measure frequencies, higher frequencies anyway. If you want to measure frequencies, use a frequency counter. So the next mode here is duty cycle. Now because this is putting out a sine wave, because it's AC calibrator, 50.5 is what's measuring there. And if it is out by 0.5%, does it really matter most of the time? Probably not. But it is reading at least, so that's 1 kilohertz. Let's change the frequency down. See if it changed anything. Nah, see now it's a bit more jittery, but otherwise alright. So now I've changed onto this mode over here for frequency, and now it's actually reading really easily. So maybe that other one there is like a high voltage frequency measurement. This is a more general frequency measurement, so maybe my previous assumption that it's struggling to read above that frequency is wrong, because I'm doing 1 megahertz at 1 volt and it's reading it just fine. So it's come down 100 millivolts, still reading it. 2 millivolts. Yeah, it's dropped off there. Okay, let's find out what it actually goes to. Let's do 100 millivolts again and bring it down. Okay, about 80 millivolts is where it starts to read. There we go. That's like the threshold for that 1 megahertz, which is okay actually. That's alright. Even a frequency counter is going to be that kind of level really. Maybe slightly better, not much. So here I've also gone to duty cycle, 1 volt as you can see, 1 kilohertz, and we're getting 51% duty cycle. So the spec for duty cycle was plus or minus 0.1% plus or minus 2 counts. So now I'm doing DC current. This is doing 1 milliamp. We're getting slightly low readings here. Maybe the microamp range would be better for this one because it goes up to 1 milliamp as well. So it's right at the bottom of that range really. So 10 milliamps, so it should be a bit more comfortable for it. Okay, it's still reading slightly low though. 100 milliamps. That's alright. A few counts out, it's not too bad. So DC current has got an accuracy of 1%, so that's within spec I guess for the range. Let's do 1 amp. Okay, that's 0.2, that's alright. Now this can go up to 1.9 amps. Fortunately I don't have a higher current source for this. So 1.9 amps. So now doing AC, true RMS, it's got on this display there as well. But 1 milliamp coming out, it's not seeing it. Could be frequency related, just try frequency difference. Let's try 100 hertz. Didn't change anything, so 1 milliamp you can't see. Microamp range might be the better range to you for that. Let's do 10 milliamps. It's down slightly. It's 1 kilohertz again. Okay, that's alright. 100 milliamps, that's looking pretty good. A couple of counts out. 1 amp, pretty much bang on, it's only 1 count out. And let's try 1.9, 6 counts out. That's not too bad. So let's test the microamp range out. So I'm in AC still because it's convenient. Let's do full range on that, 100 microamps. And it's reading it alright. So that also uses a different port, so we use microamps over here, not over here. So that's something to watch out for if you're doing that measurement before. the 1 milliamp, which should be the top of the range. It may or may not do it. No, it says no. Should be down a bit. 900, 901. 0.1% out. Let's do the DC version. So there's 100 microamps on DC. Let's go down, say 10. DC 10 microamps. You can read that. 5, yep. 1 microamp. Yep. That's doing fine. Well, so now I've changed to my resistance calibrator. I could do it on here too, but I prefer this one, it's a bit easier. So we're doing a short one here right now, and we're getting 0.5 resistance. So it's already showing something. I don't think it's got a relative mode, is it? I'm not sure. I don't think it's got a relative mode on there. May not do. So we've got 0.5 ohms with a short. So let's go up to 1 ohm. And as a result, we've got a slight offset there. Resistance is 0.5% accuracy. So at 10 ohms, we've got 0.6. Again, we've got that 0.6 offset there. So it could be lead resistance, could be a small offset in the meter itself. Actually, we can check that. So there you go, I've put a shorting plug in here and it's basically reading 0 ohms. So that 0.6 ohms is probably lead resistance and perhaps contact resistance in the relay as well. I think we're doing 2 wires, not as accurate for that. So let's keep going up. So 100 ohms. Again, we're going to have a slight offset there because of the cable. So 1k. 10k is looking pretty good. Bit of variation there. 100k. Oh, it's about 10 counts out, that one. So 1 mega ohm. Bang on. Can we do 10 meg? You can. Almost. So this is rounding up very slightly. So it's just gone slightly over. So resistance doesn't look too bad either. So that's right. So let's check capacitance next. So I've got my standard capacitors here. I've got my 200 picofarad cap here. Let's see what that measures. 165. 35 picofarads out. So capacitance is basically plus or minus 2%. Oh, sorry, in this largest range, below 10 nanofarad is a 5% accuracy error, which will be this digit here. So that's within spec. Let's plug this one in. So this is a 1 nanofarad, and it's getting 1.01. And so 1 nanofarad is a 5% spec on that, because it's less than 10 nanofarad. So that's actually pretty good. So this is a 20 nanofarad, and it's actually measuring 2.07. And that spec there is plus or minus 2%, so that's actually pretty good. So this is a 1 nanofarad. That's pretty good. Alright, let's measure. Let's have our first scope, come on. Professional YouTuber. Don't forget to click the like and subscribe. Let's measure a 120 microfarad cap. It says 109. Okay. Let me see what this says on my the LCR meter up here. I'll just tell you what the reading is when I look at it. So my other LCR meter at 100 Hz says 105 microfarad. So that's not far off. It's only 4 microfarad difference between the two. So that's not too bad. Let's see if we can read this 1000 microfarad. What's it supposed to go up to according to the specs? Obviously the capacitor's still charging up, so it's going to be drifting upwards till it settles. So it's supposed to be able to do up to 10 millifarad. It's getting closer and closer all the time. It's obviously charging the capacitor up. So we have more 10 millifarad. Okay, it's pretty much there. I mean 992, right? 993 we'll call it because it is still creeping upwards. I'll just hook this onto here and I'll go and test the other capacitor on my other meter. I'll test it in the other one. So 993 we'll call it because that was still drifting up. The other meter says 951. Which one's more accurate? Yeah, this is 951. So that's my East tester LCR meter, which is on my bench here. My DER, I could get that out too. And this is say a 10,000. So it's 100 out. I need to measure this one too on the bench meter. Is that still creeping up? No, that's stabilised. Let's measure this on the East tester as well. That's saying 9.2 millifarad. So again, the East tester is reading lower. I'll have to get my DER out just to make sure, just check it against that. So my DER says 105, which is closer to the East tester on the first capacitor. And on the other one, 9.19 millifarad, 1.2. So again, that's closer to the East tester. So my DER and East tester basically agree this is reading a bit higher. So I was doing a quick teardown. Yeah, 4 self-tapping screws. You have to get in there with a sponger down the side. Batteries come out with the PCB, that's nice. Chip on board, usual stuff. A couple of tiny little fuses. So a 200 milliamp fuse and a 10 amp fuse over here. And there's a big shunt down there. One of my favourite caps right there. Chong X cap, quite common in Chinese equipment. They seem okay, they're not the best caps, but they seem to be alright. I haven't had to replace any yet, so it says something for them, I suppose. Some MILF resistors, doesn't like them. There's not really much to see in here. That's what's in it. Not a lot. Actually, I'll even turn it around for you, like this. Make it bigger, bigger, go zoom. Or is it enhance? Enhance. That's what I do in the movies, isn't it? There you go. Nice close view. Not much to see. There's a button up there. It's a button pad. That's interesting. What that's for? Switch 3. Curious. So when it comes to protection, this thing, well, there isn't really much, is there? There's no MOVs I can see. There's nothing on this side of the board. You've got a diode there, that's about it. What that's used for, I don't know, but yeah, I don't really see any input protection. There's nothing on the back of the board, I don't think. Can't see anything on the back of the board. Just a switch, so I can see there. So, I'm not sure about the cat ratings, to be honest, because, well, there's no protection. So there you go. That's the Aneng AN8008. Hope you like and subscribe. My summary of this is that it's an okay meter for hobbyists. If you're using it for anything more serious, like high voltage stuff, above 100 volts or so, I'd say probably want a different kind of meter, based on the fact there's no input protection. Probably not a good thing. I mean, I can measure it, obviously, as you saw, but accuracy is not as good as the Coweets I did the other day. It's okay. It's a cheap meter. It depends on what you need. If you're not measuring anything high voltage, it will do you just fine. Accuracy is okay-ish, you know, it meets the spec. Catch you later. Watch out for my future reviews. Other meters, like this one here, and this one here. Coming soon to a screen near you, on YouTube, on my channel. That's where you need to subscribe, so you can see them. Bye.